2019, Day 7, Part 1, Amplification Circuit. Based on the navigational maps, you're going to need to send more power to your ship's thrusters to reach Santa in time. To do this, you'll need to configure a series of amplifiers already installed on the ship. There are 5 amplifiers connected in series. Each one receives an input signal and produces an output signal. They are connected such that the first amplifier's output leads to the second amplifier's input. The second amplifier's output leads to the third amplifier's input, and so on. The first amplifier's input value is 0, and the last amplifier's output leads to your ship's thrusters. The elves have sent you some amplifier controller software, your puzzle input, a program that should run on your existing Intcode computer. Okay, so we don't need to enhance Intcode this time. Each amplifier will need to run a copy of the program. When the copy of the program starts running on the amplifier, it will first use an input instruction to ask the amplifier for its current phase setting. Each phase setting is used exactly once. The elves can't remember which amplifier needs which phase setting. Okay. Our program will then call another input instruction to get the amplifier's input signal, compute the correct output signal, and supply it back to the amplifier with an output instruction. If the amplifier has not yet received an input signal, it waits until one arrives. Okay, so we assign a value 1, 2, 3, 4, and 5, or 0, 1, 2, 3, and 4 to each one of these amplifiers. And then run the code until it outputs something. So we have to supply it 2 things. We supply it the current phase setting, and then the input signal. And the input signal starts off at 0. And whatever comes out of amplifier A gets fed in as the input signal to amplifier B, but only after we give it its phase setting. All right. And the rest of this is just describing that. Here's some example programs. Max thruster signal 43210. Max thruster signal. Oh, I see. So this is the phase setting. Okay, so we run this program, and this should be the output if we give it the phase sequence of this. I see. Try every combination of phase settings on the amplifiers. What is the highest signal that can be sent to the thrusters? All right. Get input 2019 day 7. All right, that's a reasonably short program. I can see here, the first thing it does is input value 3, input a value and store it in location 8, 1, 3, 4, 5, 6, 7, 8. So it's a 0 here. Then it adds 10 to that value. And stores it in 8. And then I forget what 5 is now. That's probably comparison. Okay. I'm not going to decode it. So I think we just, grab these inputs and whatnot. Let's set up for day 7. Okay. And then create this module. Jump to the module. Change $1 to 19. And change $2 to 7. And then we get bacon over here. Run. Unsolved. Okay, so part 1 is just going to be getting the input and parsing it. Let lines equals AOC lib, read lines, input 2019-07 text of 0. I don't know if I can do that because sometimes it says, oh, you don't have a thing. Yeah, you have to clone it. Right. And then we're going to say computer is int code. And then we're going to say self computer equals int code new lines. We'll just call it program. Okay. We can get away without the cloning if we say lines here and then say lines of 0, I think. Nope. Yes. Okay. So what I want to do now is, I guess what we can do is we can run this as a test, right? Yeah. Config test mod tests use superstar. Actually, we don't need to do that. We should just be able to import encode directly. Example 1. Let computer equals int code new. And then we're going to, actually, we need to create 5 computers, right? Do we? No, we don't need to. We can just reset between each one. So we're doing to do a phase setting 43210 and see if we come up with 43210 as the output. So we'll say computer.push4, computer.push0. Let result equals run, computer run until output. And then we'll do a computer reset. Computer push 3, computer push result. And we just do this again. And then we can just do this a few more times. This is 2. This is, oops, 2, 1, and 0. And then we're going to just assert oh, yeah, unwrap. Got the unwraps. Like this, and we just assert that it's 43210. Right? Oh, I'm typoed computer. Okay, let comp 2 equals 0. Okay. Test. Here. All right, so it came up with the right answer if we just do it this way. I probably should write a little function that does it for us instead. Yeah, let's try it that way. So I can say pub, I could fun run sequence, self, and then the sequence is just going to be a vector of I64. And let's just say here, self computer reset for num in seq. This is probably going to want to be this instead. For num in seq, we say self computer. Let mut data equals 0. And this is going to be I64. Push num, self computer push data. Data equals self computer run until output, unwrap, and then just return data. Okay, like that. And we're not using run sequence. Let's try using run sequence. Let mut AOC equals AOC 2019-07 default. AOC.computer is that. And now I say AOC. Let's get rid of all of this. And AOC run sequence. And we're going to give it 43210. Ooh. Run until output did not work. Why? Oh, because I have to reset it each time. All right. So then we should be able to do the other two sequences. All right. F1, change that to 2. And then we're going to give this a 0, 1, 2, 3, 4, and it should be equal to 5, 4, 3, 2, 1. Okay, test example 2 passes. Let's just do test example 3 just for fun here. And then this should get 65210. And the sequence is 1, 0, 4, 3, 2. Good. Okay, so all the examples pass, which means I think we're ready to do part 1. Part 1 is just simply self-run sequence. Oh, no, we have to run all the sequences and get all of the, with all the permutations. And I do have a permutations trait. So if I do that, if I say let mut permutations equals 0, 1, 2, 3, 4 permutations, and we got to pull this in, extract into variable. No. We want to import the permutations trait. Right, and that'll allow me to permute it. Oops, no method name permutations. Unused import permutations. Oh no, am I unable to do it on a, does it have to be a vec? I wrote this code so long ago. Oh, I have to do this permutation iterator new? I was hoping to just write this as a, all right, I guess I do it that way. That's kind of annoying. I'd rather do it this way. We can look at that later. No, it's still saying extract into variable. Use of undeclared type. Okay, so maybe it's not that. Let's go up here. Yeah, so I just do it with permutations like this. Use AOC lib permutations. What type is all? It's a vec of string. Okay. So I should be able to, I should be able to do this. Okay, so it has to be a vec. I don't have it implemented for just a slice. That's what the problem is. Okay, I can live with that. So then I'm going to say for perm in perms. Now we can say perms iter map perm self run sequence with perm max. Oh, we can't iter on that? Oh, this is a vec of I32. So we need to make it I64. I don't know why I picked I64. Still doesn't work. We can do that. Still doesn't work. Option can't be. Okay, so then we just say unwrap. And now perms doesn't need to be mutable. And the tests all pass. Well, it doesn't help. Run. 75,228. That seems low, but, you know, I'll just go with it and see what happens. Ooh, it's the right answer. Huzzah. Okay, that wasn't too bad. Git add source, git commit, AM 20, what are we in? 2019, day 7, part 1. Yeah, I think the only difficulty in this one was coming up with the permutations, but I wrote the code back in the 2015 days when I was solving the 2015 problems to do all the permutations for me. I forget how we solved this. I forget how all this works. I must have looked it up somewhere, how to do it. Anyway, we have it. It's all good. Let's take a look at part 2. It's no good. In this configuration, the amplifiers can't generate a large enough output signal. The elves quickly talk you through rewiring the amplifiers into a feedback loop. Most of the amplifiers are connected as they were before. Amplifier A's output is connected to amplifier B's input. The output from amplifier E is now connected into amplifier A's input. This creates a feedback loop. The signal will be sent through the amplifiers many times. In feedback loop mode, the amplifiers need totally different phase settings, integers 5 to 9. Interesting. Again, used exactly once. These settings will cause the amplifier controller software to repeatedly take input and produce output many times before halting. Provide each amplifier its phase setting as its first input instruction. All further input-output instructions are for signals. Got it. Don't restart the amplifier controller software on any amplifier during this process. Each one should continue receiving and sending signals until it halts. All signals sent or received in this process will be between pairs of amplifiers except for the very first signal and the very last signal. To start the process, a 0 signal is sent to amplifier A's input exactly once. Eventually, the software on the amplifiers will halt after they have processed the final loop. When this happens, the last output signal from amplifier E is sent to the thrusters. Your job is to find the largest output signal that can be sent to the thrusters using the new phase settings and feedback loop arrangement. Okay. And then fortunately, we have a couple of tests here we can test. So we're going to do, instead of 0 through 4, we're going to do 5 through 9. And we're going to use them exactly once. Okay. And so each one, so I was kind of cheating here by resetting the computer between each loop because that's how I restarted the amplifier. But now we're going to have 5 separate amps. Does this implement clone? It does now. So I guess what we can do is run feedback. This time we don't need to take immutable self because we're going to create 5 amplifiers and run that sequence through them. Seek I64, and it's going to return I64 just like last time. But this time we're going to clone B, C, D, and E. Now what we do is we send the phase to each computer for S in, oh no, amp A. Maybe I make these, yeah, I make this an array. Right? We don't need to have like this. We just say let amps equals vec bang. Does it have to be a vec? I don't think so. These need to be commas though. Right? We'll return 0. Just to get it to compile. And then we can copy these tests in here. Test. Part 2, example 1. So we'll do this again. And we're going to say assert EQ. This number. Oh, well, let's first replace this. It's going to be this number. AOC compute run. Oh, what's the other one called? Run feedback. With sequence 98765. Consider borrowing here. Okay. Hit test. This failed. Right, because it's returning 0. Okay, so let's now implement the feedback loop. We're going to say for S in seek amps. Oh, no. We want to zip. Zip amps. Val amp in amp dot push val. Does that work? Iter zip. Oh. Can I do amp iter mute zip seek and flip these parameters around with an open brace? Oh, can't borrow it as mutable. Okay. There. Okay. We're still getting 0, but that's because, again, I haven't done the thing. Okay. Now that we figured out how to initialize it, everything, we're going to say amp 0 push 0. We're going to run amp 0 until output. I'm just going to do this in line, and then we can figure out how to make it smarter. Amps 0. Let out equals amps 0 run until output. Default unwrap. This is the output that goes into amps 1 push out, and then we keep looping around that. Okay, so loop let mut cur val equals 0. So we're going to say for amp in amps amp.push curval, and then curval equals this guy. Okay, but then we need to be able to break as soon as we hit a none. So we're going to say if let some next val equals okay, if it's a sum, then we're going to say cur val equals next val. Else, we're going to just return cur val because we're going to assume that the amplifier is done. And it doesn't like any of that. Amp is behind a reference. Use a mutable iterator instead. Okay, well, I mean, the test passed. So that's the good news. We didn't hit an infinite loop. I think I want to do it a little differently. Because I just don't like having returns in the middle of things. I know I do it a lot, but if I just say break, can I, okay, so let result equals outer oh, I have to put a colon and a semicolon, one of each. Okay. That feels a little bit better. Okay, so now I think since we can actually run the feedback loop, let's try this other one here, just to be on the safe side. This will be example 2. It's got 2 lines of data, and then this is going to have a value of 18,216 with the phase setting of 9, 7, 8, 5, and 6. Okay, let's run that. That passes. Okay. So part 2, we're going to do the same things here. It's going to be identical code, except we're going to change. It's going to be all identical except for all the differences. We're going to change this to 5, 6, 7, 8, 9. And instead of run sequence, we're going to say run feedback. And run. 0. Oops. What did I do wrong? Perms iter len count. Oh, perm stack count. I know. We should be doing all of them. There's 120 permutations. And they're all 0. We're pushing the 0 on there. And then this will return none. Oh, no, that's right. That's right. Yeah, it'll return none on the first one when it's all done, but then they're all going to return none, aren't they? Let me try doing the permutations in my test and see if it can come up with that. There's only 120 of them. Actually, so let's just print them all out. For the test code. So I can just throw this in here. Right? can do this, and I can say, get the perms again. And then I can say, println, oh no, we can say for perm in perms, println perm, and it's going to be something. AOC run feedback perm. All right. So it's running them. And what was the max feedback? 98765. Oh, did I do this one or did the other one? I did this one. So 18216 for 97856. 97658. I'm sure it's in here somewhere. I can't hit slash. Cargo run. Grab 18216. 97856. Okay. So now let's just make sure that we can do it this way. AOC, so this will be perms map perm max unwrap. All right, let's see if that does what that does. 18216, it prints it right out. So why doesn't this work? Oh, probably because I need to reset the computer. That's dumb. Self computer reset. Yes, that was the bug. Okay. Why did I forget? Let's get rid of all this. Yeah, because I was cloning a whatever. Okay, so we should just do this self computer reset right at the top. This one does a reset as the first thing, so it's all okay. All right, so oh, because it's not mutable. Fair enough. Let's go to Bacon again. Ooh, Bacon doesn't like this. Oh yeah, Bacon saying don't bother storing it in a variable. You can just return the result of the loop directly. All right, if I hit run, I get this big number. And then we're going to see if this big number is actually the number that they're looking for. And it is. Yay. Okay. Yeah, I just forgot to reset the computer before running it.